Hey everyone, how are you? Welcome to a new video of Leetcode DSA series, and in this video we are going to solve the problem maximum subarray. The problem category is of medium level, but I would say it's actually a very easy problem to solve. If you are able to solve this particular problem, you will unlock a lot of different patterns which you need to know, which is going to help you a lot while solving complex problems. You can solve problems on Leetcode as well as while in interview you can solve problems like these. The complete focus in this video will be how can you solve the problem and understand the intuition behind the solution, so that if you see a problem like this in an interview, you can solve it. The focus is not only solving on Leetcode but to understanding it in depth, so that even if you see it in interview, you are not afraid of anything. Now let us see the problem. In this problem, we are given an input, an integer array. The array can contain positive, negative and zero values. The output we need to find is the largest sum of a sub array from our given integer array. So the question is very straightforward. From your given input, find a sub array which can give me the largest sum. Now you cannot return an empty array. An empty array is also a valid sub array from an array, but you cannot return it. Basically, you need to return the sum. So the sum for an empty array is going to be 0, but we don't need to return it. Our output should have at least one element in the sub array, and we need to actually return this largest sum, or basically the sum of that sub array. Now let me try to explain you the problem with the example. And in the example, the given input integer array is -2 1 -3 4 -1 2 1 -4 -5 and 4. Now let us try to find out a sub array. So basically guys, sub array is nothing but a continuous set of data from your input integer array. For example, this is a valid sub array for this particular array, a sub array of 3 elements. This is valid because the data is continuous. This is also a valid sub array because the data is continuous. Starting from this particular point, we are choosing all the data continuously. We cannot say that -3 -1 2, an array of these 3 elements, can be a sub array. It is not, because the data is not continuous. We have a discontinuity in between. Now one of the possible sub array is 1 -3 and 4. The sum of this sub array is 1 plus -3 plus 4, which is equal to 2. Now this can be a possible valid answer if there are no other sub array which has a sum more than 2, but there is a sub array which has a sum more than 2, and that sub array is this particular sub array. A sub array of 4 elements, 4 -1 2 and 1. The sum is going to be 4 plus -1 plus 2 plus 1, which is actually equal to 6, and that is going to be your output for this particular input. Now let us not jump directly into how to solve the problem in the most optimal way. If I will ask you how can you solve the problem, if you don't have the answer, let's solve it in the most brute force way you can solve it. It means in the worst way possible. The most simple and the worst possible solution can be to try to search for all the sub arrays which are there for my given input. Now, do you know how can you find all the sub array for your given input? See, one of the easiest way is you start with the first element. Let us assume that your sub array is going to start with this first element. So this one element can be a sub array, right? You can also say that starting with this, I can include one more element, and that can also be a sub array. Starting with the same number, if I include 2 elements, that can also be a sub array, right? So we might want to explore all the sub arrays, starting with the first number, which is -2, then -2 and 1, then this particular sub array, then 4 numbers, then 5 numbers, then 6 numbers, 7 numbers, right? Include all the sub arrays starting with -2. You can also try with other sub arrays. Don't start with -2. Now your sub array can start with 1. Can be 1, then 1 -3, then 1 -3 4, then 1 -3 4 and -1. This can be a sub array as well, right? So like this, you will start with each element and try to create all the possible sub arrays. But now the question is, can you solve the problem if you can find all the possible sub arrays? See, the thing is, you will definitely be able to solve it. If you are able to explore all the sub arrays, then finding the largest sum is going to be a piece of cake. You just need to assume that your current sum is 0. Let's say your current sum is 0. Now let's try to find all the sub arrays, and while finding each of the sub array, you will have to keep track of the sum of that sub array. Now here is the first thing which you need to learn. If you have this particular sub array, how will you find the sum? You can say the sum is -2, right? What about the next sub array? The next sub array is going to be -2 1. This is my sub array. Now how do you want to find the sum? Will you loop through each of the element? That is a bad idea even for a brute force. The thing is, what you can do is you can keep track of the previous sum. Try to think what's happening when you are adding one more element to create a new sub array. This is my sub array starting with the first element, which has a sum of -2. What about my next sub array? In the next sub array, I am adding a new element to my previous sub array. So the sum of my new sub array is going to be the previous sub array sum plus the new element I am adding, right? So this will be equal to -1. You don't need to loop back through all the elements in your new sub array. That's the first thing you need to understand. Keep track of the previous sub array instead of trying to loop through your sub array again. For example, if you want to create a sub array starting with -3, so the initial sum is going to be -3. Like this, if you keep creating different sub arrays, there will be a time you are creating a sub array, this one, which is starting with -3 and ending at 1. Now if you loop through each element, this is a worst possible solution even for brute force. So instead of that, what you will do is, when you are creating the first subarray, the sum is minus 3. When you are creating the second subarray, the sum will be minus 3 plus the new element, which is 4, which will be equal to 1. Then you will add another element in your subarray. This is a new subarray, and these are the 3 elements. The sum will be 0, right? When you are finding the sum for the next subarray, it will be plus 2. When you are finding for the next subarray, it will be plus 1. Now you can solve the problem in O of n square time complexity. You will just pick up one element for your first loop, and then you will loop through all the other elements. How this is going to help us? This is my first element. Now when I reach to this particular element in my second loop, I will say that this is my new subarray. My first loop index will always be at the first element or the initial element of my subarray, and my other index will keep moving. This is going to create different sub arrays, and we are just going to keep track of every possible sum we are going to find. And every time we just need to update our initial value of sum, which was minimum possible. We just need to update this value whenever we get a sum which is more than my initial sum. This is a correct solution for this particular problem, but this is a brute force solution which is not optimal. It doesn't have a great time complexity, but the solution is correct. Now there's a catch, and this is the catch you will need to understand, and this is something you will understand if you have solved at least few questions of this particular pattern, where you will have to deal with a sub array, and you will have to return a sub array which is not empty. It cannot be empty. This is another test case. For this particular sub array, all the elements are negative, right? Now, if all the elements are negative, what will be your output? Forget about any programming language, forget about any algorithm. Just tell me the output. If you are saying the output is 0, it is completely wrong. Reason being, do you have a sub array which can produce a sum of 0? No. In that case, what should you do? See, the thing is, I already told you that a sub array of one element is also a sub array. It is also valid, right? If all the numbers are negative, mathematics says that if you add two negative numbers, for example, minus 2 and minus 1, if you add this, the output is going to be less than both the numbers, right? Because you are adding negative to a negative number. The output is always going to be less. And this is a normal mathematics logic to understand. If I have a number A, I don't know it is positive or negative, but if I add a negative number to A, the output is always going to be less than A, right? Because ultimately we are actually subtracting this particular value, right? And we are saying that we are adding a negative value. So when all the elements are negative and I have to choose an array of at least one element as the sub array and return the sum, then I will choose the maximum number possible. The maximum out of this particular sub array is minus 1. I will choose just one element. Reason being, if I choose two elements or three elements in a sub array and create a sub array from all the negative numbers, I will have multiple negative numbers and my sum is going to be reduced. I need to find the largest sum. And guys, when I'm talking to you, I'm trying to explain you something. Always try to catch the patterns. From this particular input where I have all the negative values, I will just fetch the one which has the maximum value. I will create a sub array of just one element so that the sum can be maximum possible. For this particular data, minus 1 is going to be the output because I can create a sub array of just one element which is minus 1. The sum is going to be minus 1 itself. You cannot create any sub array which has a sum more than minus 1. This is going to be our base case. Now let us try to solve the problem using brute force, and then we will see the optimal approach to solve it. First of all, I will try to find out the maximum number in my array. And if that maximum number is less than 0, it means all the numbers in my array are negative, right? Because the maximum is negative, so all the numbers should be negative. In that case, I will just return the maximum number. Basically, I am creating a subarray of that maximum negative number and returning the sum. The sum will be that number itself. But right now we are looking at the optimal solution. Let me switch to the brute force solution where the initial logic is going to be same to deal with all negative numbers array. Then what we need to do is we need to create a variable and name it as result, which is initially 0. See, the thing is, now our result will at least be 0. Reason being, we will definitely have a positive number or a number 0 in my array, right? So our result cannot be less than 0. So this is the minimum sum I am assuming which will be there for a sub array. I need to find out the maximum, but initially let's put it as the minimum, and we will keep finding the result and updating our result. N is equal to length of numbers. I will run a simple loop for I in the range of n, and I will assume a temporary sum of 0. Starting with the first number, I will start creating all the subarrays. And then I will create all the subarrays starting with the second number. Then I will create all the subarrays starting with the third number. This is what I need to do, right? Create all the subarrays and keep the track of the sum. So here I am keeping the track of the sum in the variable temp. And then I am running another loop in the range of I to n. And every time I am updating my temp, my current sum of the current subarray, which will be equal to temp of nums of j. Now my result will be updated, which will be equal to the max of my current result value and temp. Anytime, every time when temp is going to be more than result, my result will be updated. This way, whatever subarray will have the maximum sum, we are going to store it. Now this is a good solution, but the problem is this is giving me a time limit exceeded error. I am able to pass 201 test cases out of 210. So it is a good solution, but not the perfect one. Now let us focus on the perfect solution, which is for this particular input. Let us get back to the basic. We want to find out the maximum sum. We will initially deal with a scenario where all the numbers are negative. In this case, I don't need to run two loops. I just need to find out the maximum. If that maximum itself is less than 0, it means that our array has all the negative values, right? But now, if I have input like this, the maximum is going to be 4, right? this is indicating that I have an array of positive numbers. It means my answer will at least be 0, right? So our focus will be to try to find out a sub array which has the sum more than 0, right? Then whatever is my sum, let us say I get a sum of 2. So now next our focus will be to get a sum more than 2. Maybe 3 I get. Then I will focus to get a sum more than 3. If I'm not able to get the sum more than 3, then simply I can say that 3 is my maximum sum of a subarray. The output in this case is going to be 6, right, for this particular data or this particular subarray. But let us see our approach. Now, instead of looping through all the subarrays, just let us focus on the sum. Initially, my sum is 0, right? Now, when I see the first element, forget about other elements. When I see my first element, I have two options. Either I can include this in my subarray, I can exclude this from my subarray. Let us try both the options. If I include this in my subarray, my current sum is 0, right? I have a result which is 0. Let us say that my current sum is 0. If I include this, my current sum will be 0 plus minus 2, which is actually equal to minus 2. But I already know that I will definitely get an answer which is at least 0 or more than 0, right? So I don't need to include this at all. Now this is a way to eliminate this particular data. I don't want to use this. What about the next data? The moment you see the next data, don't worry about the other data. Try to think in one piece at a time. Try to solve it in one bit. Don't try to rush. If I see this data, I have two options. Maybe my subarray, which is my answer or which is my output subarray, has this 1 in this. If it has a 1, then this should be included in the sum, right? As of now, my sum is 0. I also have a variable current to store the sum of my current subarray. This is my final subarray. Do you want to include this? Yes. Reason being, if I include this in my current sum, the sum is going to be plus 1, which is equal to 1, which is actually more than the previous result we have. As of now, I don't know that I can create a subarray of sum more than 1. But definitely, if my current answer is 0, I can create a subarray of just one element, which is 1 itself, and the sum can be 1. So at this point, I will say that, okay, 1 is the part of my answer. It is not the answer for the global solution, but locally, when you don't know about the future data, you are saying that this is the subarray we have as the answer. Now our current answer will be 1. Now the moment I see the next data, see, the thing is we are creating a subarray. If we are assuming that this is my subarray starting with 1, and we want to include more elements to increase the sum because we need to find the largest, so we definitely need to include this minus 3. Now the moment I include this minus 3 in my current subarray, the output is going to be minus 2. An output of minus 2 means that if you start creating a subarray from 1 and include the next element, you are having an output less than 0. I know that my answer cannot be less than 0, right? So at this point of time, I know that I will not include minus 3. If I do not include minus 3, then my current sum will be back to 0. Reason being, if I have not seen these elements and if I have only seen these elements, my subarray will not have minus 2, will not have minus 3. I just have one possible subarray as the answer. But let us focus on the future data as well. So for the future data, I will not include a subarray of previous elements. Reason being, if I include any subarray from the previous elements, the sum is starting with a negative number. If I include these two numbers to try to include more numbers, my sum for these two numbers are negative. If I don't include this, my sum will be 0, right? Which is more than a negative number. So now let us focus on the next number and our current sum will be reset to 0. My global solution is still 1. Now let us include this. Reason being, if I include this, then the current sum will be 4, right? Which is actually more than the global solution. If it is more than the global solution, then I know that after I have visited this particular data, my answer can be 4 instead of 1. So let me update my answer to 4. After I have processed this particular data, my current sum will now be 4. What about the next data? Now here is the interesting part. Do you want to include the minus 1 or not? Now many of you can think that we should not include it because this is negative. My sum can be reduced. But the thing is, guys, if you include this or do not include this depends upon a lot of things. Let us say we do not include this. If we do not include this, then we cannot create a sub array starting with 4. See, the thing is, if we want to create a sub array starting with 4 to include the future elements, you will have to include minus 1 as well. Sub arrays are continuous. You cannot skip this. So what we can do is we can actually include this minus 1 and we can say that now our current sum is 3. Our current sum has reduced, but my global solution is still valid, which is 4. Now we are doing this in the hope that my later elements can give me a better value, a better output. If by adding this, our current sum would have been reduced to 0 or less than 0, then we would have ignored this 4, any subarray starting with 4, because if we start with a subarray starting with 4, later on the sum is going to be negative, and then if you start adding elements, then you are not starting with 0, and we already know that our answer will never be less than 0. So why to include an element which can make my sum negative or less than the actual largest sum? But since the sum is not negative, I can include other elements in the hope that they will make this sum more than global solution 4, and that is exactly what the next number 2 is going to do. If you add this 2, so what will happen? The sum is going to be 5. So now your output or your global answer can be 5. And that is why we are including the 4 and minus 1, because although the sum is reducing from 4 to 3, we can include the next element to make it more than 3 and more than 4 as 5. But since subarrays are continuous, we cannot skip this. If we skip the minus 1, we cannot include 4 and we have to restart from this particular point, and the sum will be 2, then plus 1 will be 3, right? So by including this, we can make a sum better. And that's what exactly we need to do. We need to select the next element, which is 1. Our current sum is actually 5. It can be 5 plus 1, which is 6 by including this particular subarray. So my current sum is 6, right? If it is 6, my global solution can be 6, right? That's my best answer as I have got as of now. What about should I include minus 5? Yes, we should include minus 5. Let's include this minus 5. Reason being, if I include this minus 5, the sum is 1, which is still more than 0. So I may include this particular subarray. This can be the subarray, but my answer will still be 6. That's the best I have got. I am including the minus 5 in the hope that later on I may get an element which is more than minus 5 and my sum can actually increase. But the next element I got is 4, which is going to be 1 plus 4, which is 5. Still my global solution is 6, and that is the actual output we have. This is the best approach you can follow. And guys, don't focus on just this problem. Try to focus on the pattern. We are just running a single loop to analyze the whole sub array. If you are able to learn this particular pattern, a lot of questions in the future you will be able to solve. This is a medium question, but if you recognize this pattern, this is a piece of cake. Now let me get back to the code editor and show you the perfect solution for this particular problem. You are going to initialize two variables, result and current. This is your global answer, this is your local answer, or the answer for your current sub array. This particular logic is going to handle all negative numbers case. Now just run a simple loop in your array or list for n in nums. If you are adding your current element n in your current sum, and if that is more than 0, then you will say that your current is equal to current plus n. You are going to include this n in your current sub array, else you are going to reset the value of current to 0. And result will always be the maximum of your own result variable and the current sub array sum. And once you are out of the loop, you can return the variable result, and this is going to pass all the test cases. I can submit this and this will pass all the test cases in a very efficient manner. You can see that the runtime is good. The memory used is pretty fair as well. So we have solved this particular problem in a very efficient manner. My whole purpose of creating a detailed video on this was not to solve this problem, but to make you aware about how to go step by step and solve problems like these. I never focused on the optimal solution. My whole focus was to make you walk towards the optimal solution. And if I was able to do it, if I was able to help you in any possible manner, then make sure that you are hitting that like button. And if you have not subscribed to my channel, just make sure that you subscribe to the channel, because in next 3 months, I promise you to make you a really good coder, especially for coding interviews for product-based companies. That's it for this video, guys. I will see you guys in the next video. Make sure that you do subscribe to the channel. I want to see you guys in the next video. Thank you for watching this one.